So in this section, we are going to now be breaking down our polynomials to the simplest form that they can be. So we've done adding, we've done subtracting, multiplying, and now we're kind of doing dividing, but in polynomials, we call it factoring. So basically, what you would get after you multiply, we kind of want to go backwards to see what did they start with. So that's what factoring is, or what factoring is. So I want to see what I can divide out of the polynomial by finding what's called the greatest common factor, or you'll hear it a lot called the GCF. So we want to find the greatest thing that I can divide out of every single part of my polynomial. So I like to start off with whole numbers. This polynomial has 12, 8, and a -6. Now negatives really only come into play when you have a negative in the very front of your polynomial. So in this case, I'm just going to focus on the numbers because out front is a +12. So thinking about this, I want to find the greatest number that I can divide all three of these numbers by. So I can always divide everything by 1, but I want to see if I can find a higher number. So 12, 8, and 6, I can also divide by 2. Some of them I can divide by 4, but not all of them. So it looks like the highest number I can divide all of these by is a 2. So I'm going to divide all of them by 2. And I also want to take out as many x's as I can. Now, when I'm doing this, I would write yourself a note. You're always going to take out the lowest number of x's. So if you don't have any x's, that's your lowest, you're going to take out no x's. In this case, our lowest amount of x's is x to the third. So I'm going to take out x to the third from every single one of these. So my GCF is 2x to the third. That's what I'm dividing out of all three parts of this polynomial. So I'm going to figure that out, and I'm going to take each one step by step. So in the first one, I did 12 divided by 2, so that's going to give me a 6. And I had x to the 5th, and I'm taking away x to the 3rd. So when I do this, I'm going to subtract my exponent. So x to the 5th, and I'm going to take out 3, so I'm left with x squared. Then I had 8 divided by 2, so that gives me a +4. And I had 4 x's, and I took out 3, so I'm left with x to the 1st, or just x. Then, last one, I had -6 divided by 2, so that's going to give me a -3. And I had x to the 3rd, and I took out x to the 3rd, so I do not have any x's left. Now, I'm not done because there's one part that's super important. I took out the GCF 2x to the 3rd. So how I'm going to write this is whatever I had left in parentheses, and I need to put my GCF out front. Because if I were to multiply this back out and distribute that 2x to the 3rd, it should get me right back to where I started in the problem. So if you want to pause and try the next two on your own, you can do so now. Alrighty, so now that you've tried those, let's check your answers. So on A, it looked like we could divide both of them by 1, which is great, but I want to look for a higher number, and it looks like I can divide both of them by 3. So I'm going to divide both of them by 3. And then I also wanted to see if there was any x's I could take out. Now remember, I'm always taking my lowest amount of x's out, which my 18 didn't have any x's. So I cannot take any x's out. So in this case, my GCF is just a 3, which is okay. I can have just a number. So what I'm going to do is I'm going to put my GCF out front, And then I'm going to put whatever I have left over inside parentheses. So I had a 15 divided by 3, which is going to give me a 5. And then that x squared did not change because I did not take out any x's. And then I had an 18 divided by 3, which is going to give me a 6. Now, if I were to multiply this back out and distribute that 3, I should end up with the exact same thing that I started with. Okay, looking at the next one, we had a negative 18, a positive 6, and a positive 24. Now, if you remember what I said earlier, we always, if we have a negative out front of our polynomial, which we happen to have, a negative 18, we need to divide everything by a negative. This is super important, especially when we keep learning more about factoring. So if you want to write yourself a note, take out negative when in front. So I'm also going to figure out what number I can divide all of these numbers by. I can always divide by 1. I could divide them all by 2. I could divide them all by 3. And I could divide them all by 6. So since I'm trying to find the greatest common factor, I want to take the highest number, which is a 6. So I'm going to divide them all by that 6, and since I want a negative to come out, I'm also going to divide by a negative. So I'm going to divide them all by negative 6. Then I want to look for how many y's I can take out. So I'm looking for my lowest amount of y's. So that would be a y to the second. So I'm going to divide all of these by y squared. So my GCF in this, my greatest common factor that I can divide out, is negative 6y squared. Okay, so let's put that GCF out front and let's see what we are left with. Negative 18 divided by negative 6 is going to leave me with a positive 3. And then a y to the fourth, and we took out y squared, so we're going to be left with 2, or y squared. Okay, then we have positive 6 divided by a negative 6, so that's going to leave me with a negative 1, which I don't really need to write the 1, because y to the third divided by y squared is going to leave me with a y, or y to the first, which I also don't have to write the 1. And then I have a positive 24 divided by a negative 6, which is going to leave me with negative 4. And y squared divided by y squared is going to cancel. I don't have any y's left, so I'm done. All right, example 2. Why is it helpful to factor out a GCF? So we first need to look at this one, and we're going to factor out the GCF just like what we did on the last one. So we're looking for the highest number that we can divide out. And remember, if we need to take a negative out, we can. So in this case, there is a negative out front. So we need to take the negative out because it's out front. So I'm going to look for a number that I can divide everything by. So it looks like I can divide everything by 1. I can divide everything by 3. And then I can divide some of them by 2, some of them by 6, but not all of them. So it looks like the highest number I can divide every single number by is 3. So I'm going to divide everything by 3. And since I have that negative out front, I'm going to need to take a negative out of all of them. And then I need to take my lowest number of x's out. So that looks like an x to the first, or just an x. So I'm going to take an x out of every single part. So my GCF is negative 3x. So I'm going to figure out what I have when I do that, and I need to put my GCF out front, that negative 3x, and I'm going to see what I'm left with. So negative 12 divided by negative 3 is going to leave me with a positive 4. And x to the third, and I'm taking out an x to the first, so I'm left with x squared. Positive 18 divided by negative 3 is going to leave me with a negative 6. And an x squared divided by an x to the first is going to leave me with just an x, or an x to the first. Then I have negative 27 divided by negative 3 is going to leave me with a positive 9. And an x to the first divided by an x to the first is going to cancel out and leave me with no x's left, so I can close my parentheses and I am done. Okay, if you want to pause your video and try out the next examples on your own, do so now. Okay, now that you've tried those examples, let's check your work. So on this first one, this in front has a 1x to the third. So really the only thing number-wise that I can divide this by is 1. So I'm dividing them all by a 1, which I really don't have to write, but I'll do it anyways. Then I have to divide my lowest amount of x's out. So that would be an x, or just an x to the first. So my GCF in this one is really just an x, or a 1x, however you want to say it, means the same thing. So I'm going to put that x out front, and I'm going to see what I'm left with. An x to the third divided by an x to the first is going to leave me with x squared. A 5x squared divided by an x is going to be x, or a 5x. And a negative 22x divided by 1x, those x's are going to cancel, just leaving me with negative 22. All right, in the last example, we need to figure out what we can divide out first. So it looks like I can divide all of them by 1. I can divide all of them by 2. And I can divide all of them by 4. So also, since I have that negative out front, I need to divide all of them by a negative 4. And then I need to take my lowest amount of y's out, which happens to be y to the third. So my GCF in this one is negative 4y to the third. So I'm going to put that GCF out front. And let's see what I'm left with and put that in parentheses. So negative 16 divided by negative 4 is going to be positive 4. And y to the 6th divided by y to the third is going to leave me with y to the third, 6 minus 3. Then positive 28 divided by negative 4 is going to leave me with negative 7. Y to the fourth divided by y to the third is going to leave me with y to the first. I don't really need to write that one. And negative 20 divided by negative 4 is going to be a positive 5. And y to the third divided by y to the third is going to cancel out, so I'm left with no more y's. Now remember, you can always go back and check your answers by multiplying it back out and making sure that you get the same thing that you started with.